All right, so I'm going to explain how to do this assignment. I'm also going to read it to you for those of you that need to hear the story in order to understand it. So bear with me. So I'm going to read it. I'm going to do a little highlighting. You should do the exact same highlighting that I do. And then I'm going to do example 1 for you. You should copy it down. And then you're going to do 2, 3, and 4 by yourself. Okay, so here we go. So let me get my markup tool ready here. So, background information. Antoine Lavoisier was a French chemist who did most of his work between 1772 and 1786. He built a magnificent laboratory in Paris, France, and invited scientists from around the world to come and visit. Lavoisier conducted numerous controlled experiments. He published 2 textbooks that helped organize chemistry into a comprehensible science. So this guy was the guy that we attribute to discovering quote-unquote chemistry, which leads me to the last sentence. Based on his contributions to chemistry, Lavoisier is commonly known as the father of modern chemistry. I need you to highlight that because that is super important. Lavoisier's most famous experiments involved the combustion of substances such as phosphorus, sulfur, and mercury. You should highlight that. He proposed that air is composed of 2 parts, one of which combines with metals to form new products. This part was later named oxygen. So he discovered oxygen, he just didn't realize that's what it was. We did that for him once he passed away. Lavoisier believed that when a substance burns, oxygen from air combines with that substance to form a new substance. His experiment showed that the new product weighed more than the original substance by a mass equal to the amount of oxygen that reacted with the substance. That's a lot of information. Just keep reading. It'll make a little bit more sense here in just a second. So these experiments led to what is currently known as the law of conservation of mass. Highlight that. You need to know that. This law states that mass can neither be created nor destroyed. It can only be converted from one form to another. Highlight that. Initially, Lavoisier's conclusions were not accepted by the scientific world. That's natural for all, what I would say, older scientists. They discovered something really cool about science, but no one really gave them credit for it until after they were gone. That's the tragedy. So initially, Lavoisier's conclusions were not accepted by the scientific world, but they eventually led to a revolution in chemical thought. His work ultimately led to the basis of Dalton's atomic theory, which you'll learn about Dalton's atomic theory in high school when you take chemistry and or in college. Not really pertinent to this class right now. Cool. So let's go to the directions. So the directions say this. Examine the data for each of the following combustion experiments and answer the questions based on the analysis of the data. So let's review real quick. So since the law of conservation of mass says that mass can neither be created nor destroyed, it only changes form, then that means that everything on the left side of the chemical equation has to equal everything on the right side, because we can't just make something disappear or create it out of thin air. It just changes forms. So 48.6 grams of magnesium, when it's mixed with 32 grams of oxygen, all it is just it's going to change forms. It's going to mix together, and it gives us 80.6 grams of that new stuff, which is magnesium oxide. That's all that means. So get your text box ready. So it wants to know what's the mass of the reactant. Remember, the reactants are the ingredients going into the chemical equation. So the mass of each reactant is this. And I would literally type this. Magnesium equals 48.6 grams. Don't forget little g, or I'm marking it wrong. And oxygen equals 32.0 grams. Again, don't forget the G, or I'm marking it wrong. Question 1B wants to know what's the mass of the product. Remember, the product is what you get after you mix everything together in the experiment. So when I take 48.6 grams of magnesium and I combine it with 32 grams of oxygen, I get 80.6 grams of magnesium oxide. So what is the mass of the product? The mass of the product is 80.6 grams. And just go ahead and make sure that you put in here magnesium oxide also. Ooh. You getting this, Mom? Just joking with you. What is the mass of the product? So it's 80.6 grams of magnesium oxide. Now, be careful. Question 1C is not asking you what's the total mass of the product. It's asking you what is the, hold on, wait for it, the total mass of the reactants. Well, there's two ways to figure this out. You know that you can either take these two and add them together, and that gets you that, which will get you 80.6. Or you can just go, oh, well, I already know that the law of conservation of mass says that everything that's on the left side has to equal what's on the right. Well, this stuff has to equal that. So the total mass of the reactants is, get my text box, 80.6 grams. And will you go ahead and label that magnesium oxide just so that I know that you know that we all know that the reactant is magnesium oxide. Last question. Question 1D says, does this experimental data, so does all this support the law of conservation of mass? In other words, do we prove that matter wasn't destroyed or created out of thin air and only changed form? Yes, it does. So all I want you to do is type this. Yes, this experimental data does support the law of conservation of mass. Now, are we done with that? No, we're not. We still have to explain how we know that. You just need to tell me this. So yes, the experimental data supports, that should be supports, the law of conservation of mass. Because I know that the mass of the reactants must equal the total mass of the product. So copy all that down. Make sure you understand it. If you do, then I need you to answer questions 2, 3, and 4. If you're not quite sure how to answer them, please make sure that you email me, Google Hangout me, or go to meet.google.com and schedule a meeting with me using my email address. Peace. See ya. Bye.